Welcome, everybody. My name is Nicholas Silva. I'm a software engineer at Box, and this is unit testing your JavaScript with QUnit and Sinon.JS. So what is Box? We've been pioneering a new space called cloud content management. We make it really easy for individuals and companies to securely store and share their documents from anywhere in the world and from any device. We just moved into a beautiful new building in Los Altos, but we're starting a major international initiative with an office in London and data centers across Europe. Founded in 2005, we have over 600 people. 120,000 businesses use Box, 92% of the Fortune 500, and over 10 million users. And we have lots of JavaScript, which means that we have lots of old JavaScript, lots of brittle JavaScript, and lots of untested JavaScript. So earlier this year, we decided that we wanted to change this. We were going to implement JavaScript testing, starting with unit testing, in a very large code base that had never been tested before. We had a few requirements, though. We wanted testing to be simple and easy to use for our developers. We didn't want to throw up any roadblocks. It had to be unobtrusive, and it had to enable us to write tests for legacy code. Here's our solution. We decided on QUnit as our test harness. Developed by John Resig, it was originally used to test the internals of jQuery. It's been a standalone project since 2009, and it provides a very simple test framework with simple assertions. And this is what it looks like at Box. Here's an example of a very, very basic test harness. We're loading a style sheet, loading QUnit, and then loading our file of tests. Load this in your browser, and you'll get the page on the last slide, or something similar. As I said, QUnit has no dependencies. However, if your code has any requirements, you can easily just add them here. Our actual test harness is generated in PHP, loads all of our requirements, our test frameworks, the file under test, and the file of tests. Each one of these is for us a test suite. So each class or JavaScript file has its own corresponding test suite. We load only the JavaScript that we're testing as much as possible, and we attempt to stub out all the dependencies it has. So it's as much of an isolated unit test as we possibly can get. If the test harness is so simple, what do the tests look like in QUnit? Here's a simple unit test. The OK assertion is testing for the truthiness, it tests for truthiness, which in JavaScript can be pretty much any equality statement like that. And the results, success or failure, are displayed when you load your results page. Here's another test using a different assertion. The equal assertion is testing this function military time that converts 12-hour time to 24-hour time, and it asserts that the result is what you specify as the second argument. For any of these, you can also specify a string statement that will then be included in your test results for someone else. You can also test if something throws an error. We often invert this to assert that a function does not throw an error. I'm not actually sure if we have any place where we're actually testing to make sure that something throws an error in JavaScript. But QUnit provides a number of assertions out of the box, like OK, throws, deep equal, strict equal, and their inversions. We actually just extended it ourselves to provide a not OK and a not equal, or sorry, not equal is there, but not throws, because for some reason those ones aren't included, whereas they are, the negative ones are included for equals. QUnit's semi-sandboxed, which means that anything that you create inside your test or inside your setup functions is only accessible in that test. But if you touch any global variable, you can affect it for the other tests in that test file. There's actually an option at the top of the QUnit test harness to tell you when you're touching global variables. We don't actually use that because Sinon covers a lot of our sandboxing for us, which I'll get into later. The module keyword groups tests with common setup and teardown, like this. Basically, anything after a module, any test defined after a module, will execute this setup function before it and this teardown function after it. It doesn't do it before all of the tests. It does it before each test individually. So as you can see here, I'm creating a div, appending it to the document body, and then afterwards I'm tearing it down. This affords convenience, but it can often cause more trouble because if you aren't careful, you'll wind up creating something over and over again before each and every test. So if we didn't have this teardown function here, and I had this module defined in front of 6 or 7 tests, I would be creating 6 divs instead of 1, So the multiplicative effect can actually wind up causing problems if you're just using QUnit by itself. So to give a little bit of a background on some unit testing terminology, which for Sinon, what it provides are spies. Spies record arguments, return value, or the return value, the value of the this object, and any exception thrown. Stubs are basically spies, but you can pre-program behavior for them. So you can define a return value, you can define that it only applies for certain arguments and so on. A mock is basically an object of stubs with not only with pre-programmed behavior, but you can also add pre-programmed expectations. So if you create a mock and you create expectations, that will actually fail your test if the object was not used as expected. And a fake object is basically a simpler form of a mock but it fully implements the interface of a real object. So if these words are unfamiliar for you, that's where Sinon can help you. And the pronunciation of this is debated. There's actually an issue on his GitHub page that some people from my company have weighed in on. We say Sinon so that we don't confuse it with Sinon, but the actual official pronunciation is still kind of up in the air. It's developed by Christian Johansson. It provides a standalone framework independent for spies, stubs, and mocks. It can fake all XHTML requests for you, which is really, really nice. And it can fake out the system clock, which we also use extensively. It's well maintained, has an active community, and you can access it at Sinon.JS.org. All you have to do is add a couple additional includes to your test harness, and you can start doing stuff like this. This is a pretty simple spy example. As you can see, instead of a standard QUnit test, we're spying on the jQuery AJAX function and then calling getJSON. The actual getJSON function calls the AJAX function, so when we assert that our spy has been called, it will return true. Sinon provides two different ways of asserting, as you can see. You can call it on this object, which is actually the Sinon object, and assert that an individual spy has been called, or the spy itself has functions for called once, called twice. I believe called thrice is defined, as well as called exactly. You can get the arguments and all sorts of things. A stub, instead of just spying on the AJAX function, actually will replace the AJAX function with, at this point, non-existent behavior, but you can actually define any kind of behavior that you want. You overwrite the behavior of AJAX, preventing it from being called. Instead of just checking to make sure that it's been called once, as you can see, I'm actually getting the first call of that function, checking the args, and checking the data property on the arguments to make sure that it matches what I've passed in. This will actually fail because the JSON call that I have here, or the getJSON call that I have here, is not actually passing any data in. Stubs also provide the ability to create new behavior for the stub function. We often stub functions that are not relevant to what we're testing so that we can just continue through code execution. It's actually been really, really useful for testing legacy code that isn't necessarily written for testing. We can just go through it and stub most of the functionality so that we can get to the part that we're testing or the part that broke that we're writing a regression fix for. Here's the same example using a mock, a Sinon mock. Mocks are often the most elegant way to accomplish what you want in a test. It implements both a spy and a stub, but it comes with the ability to add expectations on the object instead of just asserting after the fact. So when we say mock jQuery expects AJAX once, that will fail if the AJAX function isn't called once and only once. There are a whole bunch of other assertions or other expectations that Sinon provides, and it's fairly easy to add your own. So spies, these are some of the types of functions that it provides, or that the Sinon API provides. Stubs includes everything from the spies API and adds more functionality for being able to return something. Yield and yields allow you to look through the arguments of a function call, find a callback, and essentially just call that callback, so pass through. You can also call a specific arg if you want to. Mocks and expectations implement both the spies and stubs API and add on expectations. As I said before, Sinon also provides the ability to fake the system clock. allowing you to test animations and callbacks instantly instead of having to wait. In this example, the jQuery animate call takes 500 milliseconds to execute by default. However, because we're using a fake timer, we can advance the clock manually and test the results instantaneously. QUnit handles this differently by being able to do an asynchronous test and have that run kind of in the background, but we found that that was actually more trouble than it was worth, and using a Sinon fake timer made things really, really easy to test when the thing that you're testing has some sort of time element. Sinon also allows you to fake, as I said, all XML HTTP requests, preventing all calls to your backend from happening. And it also allows you to set up, which I don't have here because it's much, much more complicated, fake servers that handle requests and provide responses, even being able to switch on the types of calls, whether it's a GET or POST call, and so on. We don't actually use that because we generally wind up stubbing out the GET.JSON call itself and having it return the JSON that we want from the server for that particular test case. But you really can do some powerful things with the fake XML HTTP request. We actually have this on by default because we don't want any of our test code to ever call back to a server. Since we're running right now in a pure unit test environment, we just don't want it to touch the server at all, and we actually had problems with this. Each developer, when writing tests, had to stub out all of their AJAX requests manually, and this worked okay. We got most of the scenarios, but after a while, though, tests started slipping through that had uncaught AJAX requests. We have a lot of legacy untested code, and it's not surprising that a developer writing a test case for a bug wouldn't realize that it was making a GET.JSON call somewhere. And it actually crashed our continuous integration system because it wasn't set up to be to have a server call to it. So it just got into an infinite loop in some sort of Selenium driver and would crash. And so our QUnit suite would fail because someone had left a GET.JSON call. So now we just essentially disable all responses from or all requests to the server so that we don't even get into that scenario at all. Sinon comes with a QUnit adapter that hooks into the core QUnit functionality. It maps Sinon assertions to QUnit assertions. It provides some really powerful sandboxing. This is what the sandboxing looks like. As you can see, inside the setup function, as well as the test, this object refers to Sinon itself. Anything created on this is available inside each test, and each test alone. They don't interact with each other. It's automatically cleaned up at the end of each test in teardown so that you can set up all of your stubs, fake objects, and object references without ever having to worry about tearing them down at the end of the test. You can even stub methods inside of an object's prototype, and that constructor, so the constructor function there, will actually be restored at the end of your test. And since QUnit runs your tests in series, you don't have to worry about affecting a globally available property as long as you use one of the Sinon helper methods. If you start messing with things and start creating globals, you can actually run into problems. And since QUnit doesn't guarantee an order in which your tests will run, you'll wind up with flip-flopping failures, where one test will fail the first time, and then another test will fail the next time, which is really, really frustrating and hard to debug. Sinon mocks are also automatically verified in the teardown step. So the mock created in the test here that expects the reload function once, you don't have to worry about asserting on that. You don't have to worry about making sure that that actually happens. In your test output, it will have really nice pre-programmed output that says something like, in this particular case, the reload function on item was not called once. It's really, really nice. So with what I've laid out so far, we were able to get most of the way to where we wanted to be. Our developers were writing tests for new features, and we were decently able to test legacy code, but we had some issues. And we had to work around them. One of which, a number of our legacy JavaScript files run code on document ready. When you load them, they do something, and it's horrible. But as I said, we only want to load the individual JavaScript file that we're testing, so we have to be able to stub any dependencies that it has. We wrote this little helper, which really basically just takes a callback and passes in the Sinon sandbox as the this object. So when you call before document ready, you give it a closure, and it basically just calls that. But it allows us to stub things a little bit more cleanly than we were doing otherwise, where we had at the top of our file, we were making sure that everything was was cleaned up properly, and it was just a lot more messy than our after we made before document ready. We also found that we wanted to test functions that did operations on jQuery selections. Developers were trying to mock around the $sign, as you can see here, and it wasn't obvious to them that what $returns is actually an instance of the jQuery object, and therefore not the same object that they had mocked. To solve this in a way that the developer would expect, I actually had to intercept calls to both Sinon and jQuery. So this is a little bit, or kind of like the flow that happens. When you call the mock function, it actually checks to see if there's an instance, or if you're mocking an instance of jQuery, and then it adds it to an array in the sandbox. If not, it just continues the mocking function as Sinon would normally. Then later in the code that you're testing, when you make a $selection, it actually checks to see if that selector exists in the sandbox and returns the mock object instead of the actual object. So, and if not, it just continues on to the normal function. So now when you mock a jQuery selector, it actually returns a mock object that you can assert on and create expectations. You don't even have to have the elements in the page for this to work. So in this particular example, you can run this with an empty DOM, and because you've mocked the .contact selector and expect something to happen to it, when your actual function, in this case update contacts, runs, it will get back a mocked jQuery object that you can then call things on, as if it were a real object. You can even define what that mocked jQuery object contains inside your test setup without even having to have anything on in the DOM. Another problem that we found was that Sinon doesn't allow you to stub or mock objects that do not yet exist in the page. So the reload items function at the top depends upon the item class, or the item function. We don't want to load that file that contains item, and we don't need it to be able to test reload items. Unfortunately, when we try and stub the item in our test, it fails. Sinon can only wrap methods on an object that exists already. There is, of course, an easy way around this. In your setup function, you can create a fake object that has all the methods that you need. Then you can stub the methods as you had previously. And everything's fine, right? Wrong. After dozens of developers were doing this for a few weeks, we had these fake object declarations everywhere. And they were often implemented differently depending on who wrote it. Other developers would add methods for new tests and then possibly affect old tests. We needed something more maintainable. So I made a function that can create full fake objects that match the interfaces of their real counterparts. It won't overwrite an object, and it will actually throw an error if you try, though you shouldn't be including the real object anyway. The only place where the real objects are loaded is in a test suite file that iterates over both the real objects and the fake objects, testing them for differences and ensuring that the fake object has the same interface as the real one. So when someone adds a new method to an object that has a corresponding fake, that test suite will actually fail. And when they go to our code review site, they'll see that they have a failing test. They can go and run that failing test. And it actually says, we have an object called previewer. Fake previewer doesn't match real previewer. And it goes through, and you can scroll down, find the failing test, and it will tell you what method doesn't exist on the other corresponding one. So now, all we have to do is call this.fake item, and we have a fully interfaced item that we can then stub. We put all of our fakes into a single file defined like this. All the definitions are the actual class name or class function declarations so that the interfaces match and nothing more. They don't define any default functionality. In your stub, you have to do that yourself. I've managed to do all of these add-ons without modifying the Sinon QUnit or jQuery cores. And so all that's wrapped up in our Sinon-box file. It's really easy to just wrap functionality in a lot of these things, and that's basically how we've done it. For reference, QUnit provides the framework, modules, tests, and assertions. Sinon.JS provides spies, stubs, mocks, a fake timer, and fake XHR, and the additional things that I've talked about, which you can come and ask me about. We haven't yet decided if we're going to release them. Some things are very specific to the way that we do things. Other things don't quite fit in with the ethos of Sinon in that it's framework agnostic. So since we're actually tapping into the jQuery $selector function, that would be not something that Sinon would want to contribute to their, or want contributed to their core. We'll probably wind up releasing it as a separate project that you can use or make fun of. And the slides and selected code will be available at that URL. And I definitely encourage you to check out our blog, which we're starting up. I'm hoping to write a blog post about this. I'll leave this up for a minute. Thank you.